All right, let's do one last example. So this looks like some examples we did in the first segment. If they give us a coordinate, like a rectangular equation or Cartesian equation, y equals x plus 3 squared plus 1, and they ask us to parameterize this, okay? So in the past, they said, well, all the examples that we did, they said, let x of t equal t. And we could do that here. If we did that, what would our y be? Our y of t would just be t plus 3 squared plus 1, and we could make our table and plot this, and that would be totally fine. They didn't give us, there's no reason not to do that. But what if we want to not be so boring? This still isn't that adventurous. But what if instead we said, let's let x of t equal t plus 3, and we kind of just randomly chose that. I know it is the same expression. But what if we just said, instead of just letting x equal t, let's let x of t equal t plus 3. Well, now we're really being crazy. Okay, so what is our y of t going to equal? Well, everywhere there's an x, we're going to plug this in. So we'll have t plus 3 squared plus 1. Right, we plugged in t plus 3 for x there. So we could simplify this to be t plus 6 squared plus 1. Wow, getting wild. Okay, and now what would we do? Now we would do the same thing. We would say, if t, let's have different values for t and x of t and y of t. So if t equals -2, then x of t is going to equal 1, and y of t will equal 17, right? I think that's right. And if t is -1, x of t is -2. Oh, no, +2. And this would be 26, right? If we plug -1 in for that. And 0, x of t will be 3, and we'll have 37. And if t is 1, here we'll have 4, and this will be 50. And our last one, this would be 5, and this would be 65, right? So let's just think, I mean, what would this original parabola look like? This would be a parabola that opens up and is shifted to the right or to the left by 3 and up by 1, okay? So that's what we're expecting. So let's look. So here's just our rectangular. Let's look at this first. Our rectangular equation, it's shifted to the left by 3 and up by 1, and it's just a parabola that opens up, okay? Here, if t is, here we could be at 117, 2, and so forth. So all of our, so this is kind of plotting just part of our parabola over here, okay? But we can see we would still be moving along this parabola. If we extended it, we'd be moving in this direction. So because we chose this exciting different parameterization, really, what has this shifted? Instead of choosing t, if we choose x equals t plus 3, we've kind of shifted where we are on the curve in time. It doesn't change the curve at all, right? But it kind of moved us this farther up the curve at time -2, right? If instead we had chosen this parameterization, at t equals -2, our y value would be 2, right? So if we had just chosen this regular x of t equals t, we would be here on the curve. But now, because we chose this different parameterization, at time 0, or at time -2, we're all the way up here already. It's kind of moved us along on the curve. All of this is to say, there are different ways that you can parameterize things. None of it will change the shape of your curve. Okay, all it will do is change where you are along the curve. And you don't really have to know more than that. I'm not going to ask you to think of different parameterizations I just want you to understand that idea, right? There are different parameterizations that exist. They don't change the shape. Okay, but I don't know if you even have any homework problems where you have to specifically do this. I think they kind of give you the format of the parameterization that they want you to use in the homework problems or that I would on the test. Okay.